think maybe we should start. Hello, everyone. Thanks for joining in. Welcome to our webinar about Kafka, client-side field encryption, and Confluent Cloud lessons learned. I'm happy. My name is Noam Dror. I run solution engineering here at SecuPi, and I'm happy to introduce our distinguished panelists today. First is Mike Mitrowski of Confluent. Maybe take a minute to introduce yourself, Mike.
Thank you, Mike Mitrowski. I'm currently the director of the Office of the CISO at Confluent. Previously was a field security CTO at Snowflake, and then prior to being on the customer-facing side, ran product security for a number of customer-facing systems.
Perfect. Sounds good. So I'm sure you know a lot about what's happening within customers using Kafka and other technologies. So that's perfect for the discussion. So let's go to Alon Rosenthal. Will you take a few minutes to introduce yourself?
Sure. Thank you, Noam and Mike. My name is Alon Rosenthal. I'm the co-founder CEO of SecuPi. Also, like Mike, been doing data security, data privacy, data governance for the last 15 years. I invented this dynamic masking about 15 years ago in my first company that later was acquired by Informatica, and then founded SecuPi 7 years ago to address both the fragmentation of the market, the fast-moving regulations and compliance challenges, especially as customers are moving more and more sensitive data to the clouds.
Perfect. So I think let's get right into our conversation. And I want to ask the first question, which is more of a high-level question, but the question is, what are the top security concerns that are important when implementing Kafka projects? Maybe Mike, maybe you want to take a first stab at it.
Yeah, so when implementing any Kafka-based project, specifically in the cloud, we see a lot of customers want to start with private networking. So how is private networking going to integrate with their software-defined networks? Is it via a private endpoint, something like private link, or are they leveraging some sort of a transitive routing technology like transit gateways, or are they using a more legacy model of something like VPC peering? Are really common in ensuring that only those trusted subnets specifically could say connect to the producer API specifically, and when integrating with their Kafka clusters specifically. Mm-hmm. The second piece, and this is very similar to what Alon mentioned, we're seeing a lot of customers moving their legacy on-prem workloads to the cloud, right? So they're looking at how are they going to modernize their authentication patterns? So maybe systems that were based on mutual authentication, whether it's MTLS or something like Kerberos that had a legacy ticket granting services. How can they re-platform to whether it's leveraging API keys that they can automate rotation, or really our desired output is moved to something like delegated authorization with something like OAuth. So getting past authentication, that also kind of leads us into authorization of really what are those fine-grained ACLs going to look like within their Kafka cluster specifically. So for being able to leverage things like role bindings and push legacy ACLs to their different Kafka clusters and topics, and then being able to really uniform enforce access control policies. So whether it's traditional role-based access control or attribute-based access control, really depends on the organizational outcomes and objectives specifically. And that really very much leads into data governance. So specifically it leads into not only role and permission management, but how you could do classification and tagging as really the foundations of data governance for downstream confidentiality controls, like we would talk about with different forms of cryptography. So whether it's encryption in flight, encryption at rest, or client-side and field-level encryption specifically. And then the last piece, and ensuring that your security policy is uniform and being enforced. It's, how can you ingest some sort of audit log? So whether you're ingesting into your SIEM for threat and anomaly detection. So for instance, measuring those logs against something like the MITRE ATT&CK framework, but also having non-repudiation where you can not only, show you're enforcing compliance through your security policies and standards, but also prove it, in the event you have to pass some sort of a third-party audit.
Makes sense. Makes sense. Alon, what do you see?
Yes, so from the security angle, we see more and more adoption of more heuristical view on that, primarily around the concept of zero trust, right? Everybody wants to get into zero trust, especially when talking about security, right? And I assume we're all meeting different angles from the same. Zero trust has now expanded from the network zero trust, which was defined by the NSA, the Department of Defense, 2-3 years ago, and now the new version of the zero trust definition, prepared by the National Security Agency and the Defense, released in July 2022, is talking about extending the old zero trust model, which was very network centric, into more of a data centric approach, with the following elements: data tagging, like Mike mentioned, the need to classify the data and then accordingly apply some type of remediations, attribute-based access control, so extending from the old RBAC into an ABAC, adding more attributes to the accessibility to the data, data loss prevention, and field and record level encryption, right? So when talking about security, right, and the zero trust is a major theme around the extended model of security, that's what we see. And especially now, as Kafka is becoming the centralized nervous system of the organization, moving flows from on-premise to the cloud, from the cloud to the cloud, and from the cloud to a third party, right? The need to apply all of those features and functions on the different topics, on the internal Kafka or the customer-facing or the third-party-facing consumers. This is something really urgent for organizations that will allow them to move and to lift more data. Also, on this regard, from multinationals that are using different clusters, Kafka clusters, and of course Confluent, to move data, the need to apply the access control, the identification, the attribute-based access control on the different topics to different producers and consumers is something that we see really on a daily basis now.
Makes sense. So if you're talking about zero trust, which is now being a requirement in the federal government for agencies, let's talk about compliance and requirements in general. What do you see around the world in terms of compliance, regulation, standards? What's happening out there that drives a lot of that security challenges within the different technology systems?
Yeah, so specifically for regulations, so we've seen traditional regulations like PCI DSS driven tokenization specifically for a long time of how you protect, say, payment card data specifically. Also privacy, so articles of GDPR or high trust CSF being able to map to HIPAA business associate clauses and things like that have driven a lot of the regulation. And obviously the advance of more privacy centric information security regulations. And that really kind of ties into also the need for data sovereignty. So specifically where you're deploying your Kafka clusters and topics. So, specifically with that, the underlying cloud service providers, ensuring that your sensitive data is also being sourced, but also remaining within that cloud service provider and staying within that underlying region is really important to a lot of our customers. And then lastly, a lot of the security policies and standards are enforced by a customer's internal policies and standards. So specifically on how critical is this workload to the business? How sensitive is the data as far as the internal data for classification to align, what security policies and standards. So this gets back to really that classification and tagging, and then what level of security is going to be applied. What level of access would be, how granular does it need to be applied to specific roles or attributes, really end to end based on not only the regulations, that internal customers' policies and standards, and then applying the technical controls specifically to that workload.
Makes sense.
Yeah, and so we see that, of course, in the large global 2000s, as we serve organizations from Australia to California, right? We see that goes and increases over time, especially around the data moving to the cloud across different workloads. Kafka to be a main one, of course, because Kafka will be pulling and moving the data from one source to the other. But then once it lands in Snowflake, once it lands in Redshift or BigQuery, or once it lands in operational environments, right? How can you extend the access control? How can you extend the tokenization and the encryption and the the identification and the re-identification of the data to ensure that it is done on a need-to basis. One common misconception around that is people think, okay, we'll encrypt the data with our key, or maybe we'll bring our own key or hold our own key, the BYOK, the hold your own key, but then they do not enforce the re-identification of the data on a need-to-know basis. So as many regulations like MISAGE, the PCI DSS, but also customers are embracing encryption and tokenization of certain workloads just to ensure that it is completely identified. But once the data reaches its target, how can it ensure that the identification of the data is performed just by the authorized users when they have a legitimate purpose in the relevant jurisdiction, if the customer has given a consent? In Europe, it's all around the deletion, right? So maybe we want to identify the data, but maybe we want to apply some logical deletion on the data, so customers who have not given their consent will keep and be completely anonymized for types of analytics on their data per their consent. So it really is becoming an extended race to protect the workloads, of course, through tokenization and encryption, but then over and beyond that, through the need to apply those attribute-based access control, and last and not least, through also real-time monitoring of access to data, right? And this is an important model that we've been preaching, that people try to rely too much on just one-dimensional data protection. They would say, okay, I'm tokenizing the data, or I will apply some more rigorous access control, or maybe monitoring should be enough. What we see is that the more regulated organizations need to embrace all of those three elements together on the Kafka workloads, and then to where the data is flowing into, right? And we would categorize that into three main dimensions: the real-time monitoring, that is really essential, who has access to our sensitive data, and then to control access on a need-to-know basis, and last and not least, to both encrypt it, tokenize it, but then to re-identify the data on a need-to-know basis. For all of those elements to work in sync, right, we need to be able to support everything cloud, right? Of course, the Kafka topics to apply the encryption, the decryption, controlling access to the data through Flink and through KSQL. But then once it lands in Snowflake Databricks, once it's landed in Postgres, or once even it lands in a NoSQL data store like Mongo and others, right? We need to keep on a consistent data protection wherever the data is, and this is in order, to keep up with the increased regulation, privacy laws, CIPRA, data cross-border controls, etc. So that's a bit how we see the world into this race of compliancy that needs to be embraced everywhere.
Yeah, makes sense. So we talked about two things. We talked about what are the security requirements, because security concerns. Inside that, we talked about encryption as part of it. Then we talked about compliance, and it sounds over there that encryption is important for sovereignty, but also in order to protect the integrity and the confidentiality of the data. So can you tell us a little bit about what's available today in terms of encryption within Kafka? So Mike.
Yeah, so specifically with Confluent Cloud, so any, encryption at flight specifically. So any of your client server connections to Confluent Cloud are always going to be encrypted in flight via TLS 1.2. And we do enforce things like HSTS, so strict transport security headers. So any sort of SSL strip or any sort of downgrade attacks are actually mitigated. And then anytime data is written to disk, so specifically we encrypt data with AES 256-bit encryption at rest. And then customers have the option to leverage, obviously, a Confluent managed key, or they can actually bring their own key. So very similar to a BYOK or a hold your own key model to actually maintain positive control over encrypting the underlying infrastructure. And then specifically, we do have a number of CSID accelerators. So to provide, full client-side field-level encryption or to encrypt the entire payload, or leverage partner tools like SecuPi to apply that level of confidentiality today.
Okay, that sounds good.
Yeah.
Alon, what do you think about it?
Yeah, so here we see the need to provide a full segregation of duties element to the encryption, to the tokenization, to the access control. So highly regulated customers that adopt SecuPi, they adopt us primarily to apply various formats of out-of-the-box form-preserving encryption and tokenization with the full life cycle of key management as the data is moving from a source to destination, but then also to continue the ability to segregate who can see the key, who can apply the decryption and access control beyond Kafka. The data moves, for example, to Snowflake or Redshift or BigQuery and others, because there also the client-side encryption and tokenization is required, right? So to extend the client-side encryption tokenization model, which is very, very important to address the sovereignty of the data and to ensure full segregation of duty of the data. Because by doing that, you can ensure that the Kafka account admins, right, the cloud account admins, whoever they might be, of Kafka, Confluent, but also of Snowflake, Databricks, and BigQuery, they can never see the data decrypted. And that's a very important notion for the healthcare, for the finance, and to ensure that the data is always encrypted in those platforms. And the only place it can be decrypted is completely segregated by the account admins, by the root owners of those platforms. And that's where the client-side encryption is really, really important. A very important distinction that we have is the ability also what we call to put an agent on the Kafka producers, an agent on the Kafka consumers that would be able to automatically encrypt and tokenize certain payloads, even if you're creating a custom producer or a custom consumer. We have this ability to sit on and to poll the different classifications, the different tags. Mike mentioned the need to tag the topics. So our agents that are installed on the producers and on the consumers automatically integrate with the data tagging, such as Peerview, Elation, Colibra, other data discovery classification tools. The agents will automatically poll the relevant tags, the relevant classifications from those data classifications, and would automatically encrypt any topic that is created either with a custom producer or with a custom consumer on the payload. And this ensures also this automation with zero code changes, right? Because as you're tagging and classifying more and more sensitive data on your sources and on the targets, you will need to recode those custom producers that can be to the thousands, right? So this ability to instrument, to put an agent on the producer and on the consumer, and automatically, based on the current tagging that is defined in Elation or Colibra or others, that's we see something very, very important to the customers, because this gives them both the level of segregation of duties. This gives them the peace of mind that critical data that already has been tagged critical would not find its way to a third party or to a certain destination without the relevant guardrails around it.
Yeah. Okay. It sounds like you kind of also explained what is client-side encryption, right? The idea of how do I make sure that my cloud provider do not have access to my data? That's one, right? So I want to move my operation to the cloud, but I don't want the cloud provider employees to have access to my data. So they won't have access to my data because it's encrypted, and they won't have access to my key because the key is not stored within within that cloud environment and doesn't have access to that key. But also to make sure that outside sovereignty, so if there's a court in the country of Liechtenstein, that they will not submit a court order to fetch data from something that resides there, or something that resides in Italy, or somewhere in Asia, or somewhere in the US. That's the idea behind that. That's why you need client-side encryption, right?
Right, and that's why both we and of course Confluent, we are extending the investment into doing more client-side encryption and tokenization into broader environments, right? So of course Kafka does it, Confluent does it to the entire Kafka workloads, and SecuPi is extending the client-side encryption with more out-of-the-box form preserving, type preserving, encryption, tokenization, more integration with the catalogs, as well as to where the data eventually lands in Snowflake, BigQuery, Redshift, and others, so we can ensure that the data, even in those data platforms, cannot be decrypted, cannot be accessed by an unauthorized user, by the cloud account admins, etc. Right? And that's why the client-side encryption, which you can see here, with this logical man in the middle, right, or an agent on the consuming applications, the decryption, the re-identification is happening completely segregated from the cloud account admin, from the Snowflake, from the Redshift, from the BigQuery, and others, and that's an important step forward into a complete zero trust that all of us are striving into to have our environments done.
Yeah. That makes sense. So we talked about client-side encryption, that it's needed. So maybe Mike, for you, the question is, what are the common concern with client-side encryption? Well, you know, what do customers ask you when they know that they need to use client-side encryption?
Yeah, specifically, and as Alon mentioned, right, so maintaining that separation of duties is extremely important between really that KMS or secrets management solution that's actually going to be providing that level of tokenization or format preserving encryption. That's really important. So I think the first piece is really performance. What's the impact from a network latency or computational overhead, specifically as a lot of the key stores today are specifically using envelope encryption, where a customer managed key is going to be unwrapping data encryption keys within these flows. And that's a really important use case. And then it's really, how is it centrally managed? So generally, you're never going to be bringing in a solution just for one application or just one system. How can they centrally manage those policies, those tags, things like that, you know, across a number of different systems? So I think the really important output that comes out of the performance conversation is, how is this usable security? So specifically, you know, are they using a non-deterministic output or deterministic output? So as we talked with client-side encryption, taking really a plain text input and having really a uniform, you know, ciphertext output is really a really common use case for things like format preserving encryption or tokenization. So depending on a company's policies and standards, you know, you could replace that with random data values to actually tokenize, or you could use an encryption algorithm with a centrally managed key for format preserving encryption. But then you have that you know, really deterministic encryption that you could use for joins across many different systems. So you have that level of confidentiality, but you also have a usability by, you know, downstreams, you know, analytic systems and processing engines. So that's a really important piece. But then different flavors of format preserving encryption have been known to be vulnerable to different crypto analysis attacks. So specifically, NIST has the 800- specifically 38 standard in special publication, where you could use FF1 or FF3-1, specifically that you're meeting the right level of confidentiality for the format preserving encryption that you're applying to your system.
Yeah, perfect. Yes, so you know, we've been investing a lot in providing libraries out of the box encryption that are FF1, FF3, you know, NIST standard, and basically they can be picked for a certain data type or data field. They include the tokenization form preserving encryption, AES encryption, AED encryption, and every one of those have, of course, the pros and cons, right? So you really need to have all the options available for you so you can choose the right encryption to the relevant column. Also, the fact that we're talking about preventing statistical hacking. So, for example, apply blurring. So blood type A+ will be encrypted to multiple values, still keeping the original value, but they will be encrypted to multiple value because everybody knows that there are more females than males in any large data set, right? So this is important, the ability to apply blurring. Other types of anonymization needs to be used, especially when you're talking about analytics use cases, right? If you're talking about the need to identify large data sets to comply with GDPR, so we're talking about bucketing, maybe even dynamic masking, just Xing out, for example, the phone number, right? So keep the country code, but then keep the remaining digits. Very helpful, very useful for those use cases. We also look at the obfuscation of data. That's primarily used when you're taking data from production to non-production or sending data for some sampling. So, for example, be able to obfuscate names, right? So they will still be looked like names, but will not be the original names of those customers. Form preserving is a randomization. The form preserving is very important to keep the length of the original value. But over and beyond that is we talk about type safe encryption, because one common misunderstanding is the fact that form preserving is enough, but form preserving is not enough simply because if you take, for example, a date, 23rd of February, and you do just form preserving encryption, it will give you some strange dates. Like 38th of 13th is also the same format. It's not the same time, but it's the same format. And that's why we also invested cycles into providing types of encryption. So to be ensured that if you're encrypting a date, it will be still a date, right? And keeping all the different date and time functions around the world for customers who are using form preserving encryption to do that for different time and date formats worldwide, but also encrypting integer into integer and long into long and even a byte into byte, right? So that's why encryption requires a lot of flexibility to apply that correctly into complex data sets. And as the regulation and the security imposes more and more identification of data, more and more client-side encryption, right? Those options are very, very important. And then also talking about the key rotation. Key rotation, the common practice is do a key rotation every year. And then the key rotation can be also sooner, even every month, but this would be rotating the key encryption key, not the data encryption key, right? Mm-hmm. So keep note that also when imposed with the question, okay, what about key rotation? What will happen, right? So the common industry best practice is to do key rotation for the CAC and not for the DEC as much as possible. So that's a bit more context around the encryption, how it needs to be affecting large data sets.
Yeah. By the way, regarding this type safe, I'm not sure that people will not want to have it 13 months of the year.
Yeah.
That might be an idea.
Maybe celebrate Christmas twice.
Right. So let's talk a little bit about what's coming next. Where do you see security in general is evolving in that streaming market, right? I'm sure streaming is going to, we already see it's growing very fast. More and more companies are using streaming technologies for different purposes. Where do you see this taking the next step when we talk about security functionality there?
Yeah, absolutely. And we see more and more of our customers want to get off of legacy batch and micro batch processing and getting into streaming. So, obviously it's understated that the value of companies' data today is really critical for their business success in the future. So doing more really in motion specifically is Confluent strategy specifically is having customers get more value out of their data in motion. So that's where we're going to see traditional streaming SQL engines like KSQL DB and Kafka, and now with Apache Flink integrating with Confluent Cloud, being able to do more joining on stream specifically, really in flight and getting more value out of that data specifically in the pipeline while it's in motion is a really common use case. So that gets back to what Alon said. So being able to maintain provable security, right? So usable security. So if you have, tokenization, preserving encryption, but you're also able to prove things like key provenance, that you have ownership over that cryptographic key, enforcing the right level of key entropy as well for that highest level of confidentiality, and then having full audit logs transparently of your policies, how they're enforced, who accesses what, what data source is serving as a producer and consumer within that stream is really the future of security. So it really applies to those mission critical business workloads, but we're also going to see an uptick of these use cases in the pipeline, specifically for security use cases for anomaly detection and threat intelligence specifically.
Yeah.
Makes sense.
Yes, yeah. We see fast adoption of Confluent, where more and more data is lifted, and there, right, as Mike mentioned, the urgency is there. Regulations are really becoming more and more eminent, and they're also more complicated. Streaming is happening all the time, and the centralization of who can see what, when, and where, whether this is people running analytics on Flink, KSQL, the different topics. Automation is really required, right? The automation of the entire life cycle through integration with data catalogs, that they can automatically tag certain topics, right, as they are being created and lifted. That's an important aspect of how to be future resilient, both for the regulations, but also to come closer into the zero trust aspiration that everybody has. So the automation is really required, as well as the ability to monitor and to control access through the entire life cycle of the data, as it is being lifted through certain producers and being consumed. Central control also of the producers and the consumers is becoming very important, right? CISOs are becoming concerned. They see the ability to pull data from Confluent, right? This needs to be controlled more and more. The openness of Confluent needs to be managed, and the CISOs need to have the confidence that whoever is consuming the data is authorized to do that. The level of the identification is appropriate to the purpose of this, and the entire sovereignty of the data is kept in all times. So all of these are coming to fruition.
Yeah, maybe another thing, at least I see, is that if everything was moving into the cloud, and now we see a push to move back to the edge in terms of real time, and Kafka is a big part of it because it's all about moving data within the edge, or between the edge and the cloud, and within the cloud. I think we'll see more and more services that are happening everywhere. So today, if services are available mainly in the cloud, centrally managed in the cloud, and all the processing is done in the cloud, I think we'll see more and more services are happening within the producers and the consumers locally before it moves. So you can tag the data, you can encrypt the data at the source, and then do whatever you need with it as it moves through the flow. I think that we are going to see a lot of that happening.
Yeah, and then have a unified model, right? From your DB2s and Oracle, through the Kafka ingestion to the consumers, right? Everything cloud, from SQL, NoSQL, right? Even Redis, right? Redis cache, right? So even those data silos needs to be protected. So having a unified model that will support everything around data from its birth to its usage, to its deletion, right? With all of the different feature sets of monitoring, access control, and identification. So encryption, tokenization, client-side or edge-based decryption, encryption, these are all really something that customers will be embracing in the future. And making the right choice of such a platform is really important, because otherwise you end up with a tokenization tool, a classification tool, a monitoring tool, an access control tool, which don't talk with each other, right? And just managing all of those different views is impossible. That's why the consolidation both of platform support as well as the consolidation of features required, that's where the industry is going, and it's super important for the regulated customers.
Sounds good. The future sounds bright.
Yes.
Okay, so that was a good discussion. I think it's time to move to our Q&A part of the session. First, everyone on attendees, feel free to type your questions in the Q&A button on the bottom of your screen, and we'll review it and answer it here. And let's start with the first one. I think the first question is talking about how do you work with encryption when you're using KSQL? So if you encrypted the data, on one side, and you want to decrypt it on the other side, KSQL kind of comes in the middle. I think that's what they're trying to ask. How does it work with KSQL?
So SecuPi, we have basically a KSQL agent that can instrument the KSQL and apply KSQL, but also even to do it on Flink, and to apply the identification, the decryption based on policies, right? So, for example, if this is an authorized user, he can see the data decrypted. But if it's a production support that is doing some kind of work on those platforms, the data will not be re-identified to this persona, right? So this is something that already have taken care of as part of the platform support, right, from the mainframe to the cloud.
Makes sense. Maybe one thing I would add on top of that is that you don't have to encrypt everything. So people usually think if I'm encrypting everything. That would have some performance implication on the architecture. You really need to encrypt the sensitive data, what is considered PII or intellectual property. If you have, I don't know, a measurement of something that doesn't identify the record, that should not be encrypted. And when you have, only part of your stream being encrypted, you can do a lot of the stuff, a lot of the KSQL queries, even without decrypting at all. Right, that's I think that's the nice thing, and I think Mike said it before, because the FPE is consistent in terms of the IDs. You can do joins, or you can do anything about the ID, because we keep the referential integrity of the data. So that's more stuff that you can do without decryption within KSQL, right?
Yeah, it gets back to the performance piece of.
Right.
From the client side, only encrypting the fields required is,
Right.
gives you confidentiality, but also that high level of performance that is required of the application.
Right.
Yeah, perfect.
Okay, let's go to another one. They ask, can we identify classifications in SecuPi to be applied in databases?
Sure. Yeah, so we have both a classification utility as well as the ability to pull classifications from all common tools such as Elation and Collibra and Purview and all others, which we have a relationship with everybody, in order to provide the holistic approach from the data discovery classification, either ours or the third party, to the actual enforcement or encryption of certain sensitive data that has been classified critical, or the monitoring of that and tagging the topics that have sensitive data within them. Yes.
Okay, so we were talking about tagging and access control, but we also talked about encryption. So one of the questions here is, why do we need access control and classification when we encrypt the important data anyway?
Right. So first, what is important data? Right? How can I find it in so many topics coming from so many sources? Right. So that's for itself requires some type of a common dictionary of what is sensitive, what is critical, and again, we do not want to encrypt all the payload, right? Because then the usability of the data, we will need to decrypt it, right? And we want to keep the data de-identified as much as possible, right? So against privilege abuse, credential theft, hackers, all of those bad things that might happen, right? We want to have the data, the critical data encrypted as long as possible, while data that is not sensitive, let's keep it in clear, right? To minimize the compute overhead of the encryption operation for performance reason, as Mike mentioned, right? So for that, we need the tagging to be performed. And the tagging not only allows us to protect the data at rest, to encrypt the data, but also to protect the data in use. Because, for example, you can define for certain personas what type of data they are allowed to see. For example, an admin should not see PII or PCI, but maybe legal or analysts should be able to see some type of PII, right? But they don't also need to see the PCI data, right? So the ability to tag the data at scale allows us to provide both the encryption, the access control, and the monitoring, right? A common theme is how much sensitive data has a person access before he left the company. And that's a common question that all CISOs around the world are asking, and they don't get a good answer, right, due to technology limitations. But that's something that the only way to reach that is by having a good tagging mechanism that based on the tags, we can assign a risk score to every topic. I think that you can even from a CISO perspective or from the owner of the Kafka or Confluent, you can apply this behavior analytics on the sensitivity of certain topics and where they go, right? And then ensure that the high risk topics can only be consumed by relevant targets, right? So that's another way to control data through the tagging and into the ability to assign a risk score for every topic.
Sense.
Yeah.
Okay, looks like those were the questions. So any final remarks, guys, before we end?
Mike?
No final remarks. Just
Okay.
thank you for having me, and looking forward to everybody to enjoy different stream processing workloads securely.
Yes, yes, yeah, definitely. We are in a fast-moving train. Need to chase the huge onboarding of data, sensitive data on Confluent and using Kafka, and it is an exciting time as zero trust with compliance, with cyber risk increasing every day, right? So looking forward for having more discussions with everybody in the meeting and continue the good work with Confluent.
Sounds good. So first, I want to thank you guys, Mike and Alon, for an engaging and insightful conversation. I want to thank everyone that joined this webinar. We're going to post this recording on our YouTube channel soon. So see you on the next webinar. Thanks a lot, everyone.
Thank you, Mike. Thanks a lot,
Thanks,
guys.
everyone.
Thanks. Bye.